Okay, this time I would like to make a document scanner using OpenCV in Unity this time. This example in this web page shows how to make a document scanner in Python. But simply I can just do the same things in Unity, so I would like to do that. Okay. So first of all, I need to import the OpenCV For Unity plugin. This is a paid version. I think you can. There's also like a open source version for C#, so you might be able to use it on Unity for free using different kind of plugins. But this one has a lot of examples for Unity, so it's pretty useful in terms of using it without the stresses. So I'm going to use this one. Okay, so the plugin is imported. Let's set up the scene first. I'll make a new folder, scenes, and save the scene to here. Call main scene, and I'll make a canvas. And I'll use a raw image to show the textures here. And let's make another folder, textures. And let's import a texture which looks like these. So this is a sample picture and I want to crop out this part, this document, and make it warp as a square piece. Scan out the square piece from this picture. So let's import this one, and let's set the known power of 2 to none so that I can use the real width and the height of the textures, and also check in the read and write enabled. Apply. Okay, and let's make some UI row image here. Also want to set the canvas to something like 800 to 600. That's fine. Let's set the first row image. Let's say it's source row image, and duplicate it and name it target row image. And the source row image, I'll place the X position to be 0 and set the size to something like 400. Oh, so 400. Well, since the ratio is around 3 to 2, so I'll make the width 300. Set the height 200 and move X to like 50. And for the target row image, set the anchor to 1 and set the size to be 300 to 300. If it's a bit too big, 200 to 200. Let's set the size of the canvas to be a little bit smaller so that it will be 600 to 400. And Let's move this 25 to the right, and let's move this 25 to the left. Okay. So this is 1-to-1 ratio, this is 3-to-2 ratio. And for the default, as a default for the source, I'll put this one here. So what I want to do is to crop out this one and place it here. Scan it here using OpenCV. So let's make a empty scanner, empty object, game object, and make a script to write a OpenCV script here. So let's create a C# components name as scanner and put it on the game object. And I would like to have 3 public variables. First one, texture2D, to set the base texture, and 2 row images. I need to use Unity Engine UI. Source row image, public row image, target row image, right? And I also wanna use OpenCV, obviously. OpenCV for Unity. Okay. So I'll just gonna do everything on void start, since I don't need to update every frame. So. Okay. First thing first, I'll make a new mat. Mat means matrix in OpenCV. And this is the OpenCV for Unity is based on OpenCV for Java. So if you look at the Java document, look at the document for OpenCV Java, then you can use like every kind of functions that Java version provides. So first thing first, I'll need to make an empty matrix using the base texture height. Height comes first. And base texture width, and set the type to 8UC3, which will be RGB color. Okay. And I'll make another matte matrix called gray matte, which will be used for image processing. This image, this main image. The main matte stays as a colored main image. For the gray matte, I'll just say new matte, and I'll use a utils. This is a function from OpenCV for Unity, and I'll convert texture2D to matte and base texture and put it into the main matte. And also let's copy this matte to gray matte. So converting the texture to D2 matrix. Copy main matrix to gray matte. And first thing do, if I use this thing, it will copy the color, texture, information into the main matrix, main matte. So first thing I need to convert this into gray scale. So in order to do that, I'll call image proc convert color. And since gray matte has the same value as main matte right now, I use gray matte to convert it to grayscale. So gray matte. This is a source. The first one is a source matrix. The second one is a target matrix. And I'll use the image proc color BGL to gray to convert from color to gray. Convert color to gray. Okay, and well, at this point we can check if the image processing is really done by doing this. So in order to do that, I make an empty texture 2D. Let's say final texture, new texture 2D, and set the gray matte width and the texture format to be, let's say RGB 24 is fine. Since we don't have an alpha channel here. Am I missing some? Okay, so I don't need a mid map, so I'll put false here. Okay, then there's a function on the utils class, matte to texture 2D, and let's convert the gray matte to final texture, and let's try to change the source row image texture to be final texture. So if I run this, it should change this colored picture to grayscale picture, hopefully. Now let's see if there's no errors first. No errors if you play it. Nope. Okay, I have a scanner, but I didn't feed the parameters here, so the source comes here, the target comes here, the texture comes on the first one. Okay, let's save this and play. Okay, so successfully it converted into grayscale image. Now let's go continue. Let's comment this. Create a empty final texture. Convert matrix to texture 2D. Alright, the next thing you should do after you make this picture grayscale, you need, in order to make a contour clearly, it's a good practice to make a blur on this image. So let's do that. So blur the image. image block. So there's a function called Gaussian blur. So use that to make a blur. So the source target as again will be gray matte, target will be gray matte, and the size of the Gaussian blur to be size 5.5. Could be higher, could be lower. It depends on the detail of the images. If there are so many noises, you should increase it. And 0. This is a sigma x. I don't really know what this parameter stands for. It always comes as 0 for me. Okay. So it's the final image. Final metrics is still gray matte. So let's check out the output image. Doesn't look blurred, but if I make it really high here, maybe I can see the difference. If I run it, yeah, it is giving me a blurred image, but let's keep it 5. Okay, now the next thing you should do is to make the image black and white so that it'll be easier for the image processing to make the contour. So in order to do that, there's a function called thresholding. So let's do that. Thresholding. Make the image black and white. Okay. Image proc, threshold, and again from source image, source matrix to target matrix, and you need to set the threshold value and the maximum value for the threshold, but this time I'm gonna use a type called threshold, which gives the threshold value automatically. So I don't, for this value, I don't need to. These numbers 0 to 155 could be random numbers. The important thing is this: the last parameter should be image proc threshold, which will determine these numbers automatically from this image, from the grayed image. Okay, let's see the result. Why am I having this thing? Okay, let's pray. Oh. Yeah. And it's giving me a black and white image. Like this. So this is thresholding. Now after you make the image black and white, what I want to do is to make extract the line on this edge of the image. So in order to do that, there's a function called canny edge, extract the edge image. So let's do that. Image proc canny, the source image gray matte, target image gray matte, and I also need to set the threshold value here, but I'll just set 50-50 as a default and save this. And let's try to play this to see the result. Okay, let's see it in the maximum play. Now you can see that the edge has been extracted from the edge of the document, also on the letters. So right now from here, what I want to have is just the outline of this 4-point cornered squares. Now, in order to do that, you use a function called find contours. So you basically have to find the contours from this canny edge. Now, in order to make that, you need to set up some, you need to have some empty variables first. So I'll prepare for the finding contours. Okay, first of all, you need to have a list of mat of point contours and new list mat of point, and let's call the find contours. Find the contour from canny edge image, which is image proc find contours, and the source image is gray mat, and put the result in contours that you have just made. And the hierarchy is okay with the new matrix, with the empty matrix. And for the mode, you use image proc RETR. Well, there are some options here. The list basically gives all the extracted contours. External just gives you the outside of the among all the external outlines among all the contours, such as if you have contours here and if you have contours here, you this will ignore the inside contour, just get the outside contour, external contours. So that's what I want this for this example, so I'm going to use this one. And other than that, you need to have a method, so use the most simple method, image proc chain approx simple. Okay, now the other things, now you get the results inside this contours. Now you have to go look at it, look at the information you have. And in order to do that, you'll use the for loop to look into it. So for int I equals 0 to contours count, and each contour is called have a data called mat of point, so I'll call it CP contour point from contours I. And in order to do some conversion, I need to use a data called point to f, mat of point to f. Let's call it cn and new mat of point to f and convert the cp to array. Okay, and also let's get the double p, which is a arc length image proc arc length, so which is the length of the edge into. Okay, now I'll make a new data call mat of point to f, call approx, new mat of point to f, and I'll use the image proc approx poly dp cn approx 0.03 times b. Well, this is a function that I'm getting it from the website and use for the document scanning. I think it's basically searching for extracting the edge that's pretty much a square-like, or have the convex to be squared, and not too thin, not too thin. Well, that's what I mean. Basically have some ratio between edges to be somehow consistent. I'm not really sure, but this thing seems pretty important in order to retrieve the edges. Okay, and if you change these parameters, if you make it larger, even if the image is really skewed, it's more likely to get it as a square. If this value is low, you really need to have the image to be really squared with the straight edge, so you can control how precise it should read using this parameter. So let's say okay, and if so what we want is to have the contour which have 4 points, obviously. So I'm making a condition, find a contour with 4 points from the approx. I guess this one is converting to a poly convex curve. So convert contour to polygon, readable polygon. Okay, so if approx to array length equal to 4, then this means that it has 4 points on the contour. So let's make a new mat.of point here. Name approx.pt equal new mat.of point and approx convert to blocks.pt to, let's, at this point I'm gonna change the color type to 32S. Okay. And I'm gonna calculate a thing called float max cosine. Let's make the variable to be 0, and for int j go to nj to 5. Basically here I'm trying to check the angle between the edge, the first edge and second edge. How much angle is this, this and this, and this and this, and this and this. So basically you have 4 corners that you can calculate the edge angle. And let's see if the angle is decent enough to be a document. So first thing you need, you'll have vector2 name v1 and new vector2 float and blocks to array j mod 4 and approx to array j -1 dot x comma float blocks to array j I think I'll just copy this. Okay, that's V1, and I also need V2 to calculate the angle. J-2, J-1, J-2, okay, let's angle vector to I'm using the Unity function to calculate the angle here. And last of all, max cosine is max cosine angle. So get the largest, the maximum angle out of all the four corners, and check if the max cosine is 120 120 degrees. Well, if I look at the edge, it's pretty close to 120. Maybe could be larger than that, like 135. And if so, temp add the contours into temp targets, name approx pt. Oh yeah, so I also need to make a mat of point temp targets new list and mat of point. Okay, so if I found good contours here, I will add contours into the temp targets list. And now after adding it, if the temp targets count is larger than 0, the count is larger than 0, then get the mat of point approx pt temp. So, well, at least at this point, I just want to get one contour. So I'll just, whatever it finds, I'll just get the first contour at this point. Well, it depends on your needs. You can definitely change the logic here based on how many documents you have. You just want to get the largest area of from tons of documents or something like that. But for now, I'm just gonna get the first one. Okay, get the first contour. Okay, now I'm making a source points mat and use that to convert this to this size, to copy this to this area. So first of all, I'll need to make a thing called source point mats, and I'm going to use converters dot vector point to vector point to mat, and you convert the approx pt, which is the vector information, to a CV type CV CV32F, which is a float or double number. Yeah, I guess it's a double number. Okay, now I also need to make a destination point. Now this one is, the source point is something like 1, 2, 3, 4, the corner points. And for this one, I need to have 1, 2, 3, 4 corners of the square. So let's make that. This point. This points, new list. This points, add new point. Points, add new point. This points, add. Okay, well, I have just set the size of the square to be 512. Could be any numbers, I guess, but 512 is, I thought, is good. So I'm just gonna set like that. And finally, I'll make it as a mat matrix. Mat dst points. Mat converters vector point to mat dst points cv type cv32f. Making destination mat. Making source mat. Okay, now since the images has a perspective, let's make, in order to warp this image, this perspective image to a flat square image, I need to give a perspective transform. So let's do that. Make perspective transform. I call that m mat m equal image proc get perspective transform source points mat destination points mat. So from source points mat to destination points mat, I'm making a perspective. I'm getting a perspective transform from this. How should point? Well, should transform from source to target. Okay, and let's make a new mat called warped mat, and the size of main mat and the type of main mat, and I'll call warped mat. I'll convert the warped map to CV type CV. Oh, before that I need to call a warp perspective. This is the function that actually transform this one to this image, this perspective image to the square image. And basically what warp perspective does is that you input the main image, the colored image here, and you also input transformation information, which I have just made, this M, so that it will crop the image from the base, just this part, and convert it into the square image. Now, main mat, and feed it to warped mat, and use the perspective transform M and the new size 512, 512, and last image proc linearly transform. And right now this is a float value, so let's convert this into CV type to CV8 UC3. Crop in. Okay, now finally let's copy paste this one here, and I'll have the final texture, the size to be the size of warped mat. And the height, this will be the size of the height warped mat. Okay, and convert the warped mat to final texture, and I want to change the target row images texture to final texture. Now let's try that out. Play it. Done. So yeah, making a grayscale, making a black and white image, making a contour out of the black and white, then make a transformation, crop it and warp it, and you have the scanned document like this. That's all about it. Now it's pretty simple once you know what it's doing for the image processing. Okay, that's it. Thank you.